Okay. So here we are, we left off at number 10, is that right?
Right.
And Will made a comment at the beginning of class. He said he slept since then, right? So have I. And that's a valid comment. That's one reason I wanted to straddle this over the weekend. So, anyway, kind of the format, the way we talked about last week was this. Does this look familiar? Okay, so we put x, f of x, and then 1, 2, 5, 7. And then what goes next?
You put the mx plus b equals 1.
So mx plus b is equal to f of x. And then what is our slope going to be? 5 over 4. So m is equal to 5/4. So here we use the mx plus b. Well, m is 5/4. In this case, x is 1 plus b is equal to 2. So 5/4 times 1? 5/4. Plus b. And how many fourths do we have in 2?
8.
8/4. Yeah, 8/4. That looks good. And subtract out 5/4. So b is equal to? 3/4. So now, do we have an equation to deal with? Yeah, we got y is equal to 5/4 x plus 3/4. And then we can graph this thing by going up here at x equals where's our y-intercept here? 3/4. Is that it? Is that about here? And then 5/4 up 1, 2, 3, 4, 5 over 4. 1, 2, 3, 4, so about like this. And then our line looks something like this. Not the most perfectly straight line I've ever drawn in my life, but probably for this class may not be so bad. And then we mark where our points are, 1, 2. Does that work out?
Yes, and it does.
And then 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's pretty good. Okay, so really that's it. Does this bring back some memories, fond or otherwise, does it bring back memories, Kinsey? Not good ones?
Yeah.
These are bad, sad memories? Okay, I didn't quite get that. I didn't quite get that. That's all right. That's all right. But no question on this one? Okay, let's go do 11 and 12. They, in some respects, should be even easier. And I'm going to ask you why after a minute, why 11 and 12 might be easier.
I already have an answer.
Why did you already have the answer?
It's on the video.
Oh, you saw the video?
No, I said they look like animals.
They look like intercepts. Yes, they do. Yeah, so Kaylee's right. You said they're intercepts? Yeah, they're intercepts. See? Very good. See? You're just like distinguishing yourself like nobody's business in this class.
And also,
Also what?
my head.
Your head hurts, okay.
These are working there.
All right.
It's the opposite of what you
Gosh, it's green. Well, can you see that one? wanna do the blitz on yourself? I can't come.
Can't ever.
Okay, what, who has number 11 worked out yet?
I got the,
Okay, Emily, I want you to give me the equation and we'll kind of check it. What do you get?
y equals negative 1x or negative x plus 4.
Plus 4?
Yeah, that's what I got.
Plus 4. Does that look right? Okay, let's test it out.
Wouldn't it be plus 3?
Yeah, it probably is. What is this? This is a what? It's a y-intercept, right?
Yeah.
Yeah, so this one should be 3 actually, shouldn't it? How'd you come up with 4?
Oh, never mind. Yeah, it's 3. I messed up.
Okay. Well, the thing that's good about this is you got your things you can check. So you got x, f of x. So then you have 0, 3, 3, 0. So that's negative 3 over 3.
I just forgot the times.
Oh, really?
Negative 1, 0.
Okay. So m, I get is negative 3 over 3. And so we have, if we have mx plus b equals 3, in this case m is negative 1, x is 0, plus b is equal to 3. So we got b is equal to 3, is that right? And so we have y is equal to negative 1, or negative x, plus 3. And then we can graph the thing right here by going up to our y-intercept, then rise over run, down 1 over 1. So look something like this. And then, of course, you have your intercepts marked right here. So that checks out. So we have 3, 0, 0, 3. Okay? And 12 should be similar, but not exactly the same. Yes, you got 12 worked out?
I think so.
Okay, great. Let me, Kayla, if you could you tell us what you got for 12?
Y equals 1/2 x plus 2.
I got 2x plus 8.
I know what Haley was. Yeah, looks like.
I have confusion.
Wait, what?
Okay.
I'm not explaining this one.
What I want to do first, and one thing that Kaylee did earlier in class was good.
What?
You okay?
Not gonna headache.
Okay.
Same.
See, one thing Kaylee did in number 12 is she recognized the intercepts, right? And do we have a similar situation here? Do we have a similar situation here?
Yes.
Yeah, we do. So we have that intercept and that. So we know that B is equal to 2, right? Just here, so that checks out. What about the rise over run? We have here up 2 and over 4. So up 2 over 4. So we have 2 over 4 is equal to 1/2. So that checks out, right? And then then the line, of course, goes through these points. So is there anything more to be done with this? Those of you who did not make a mistake on that, if anybody made a mistake on this, did you figure out what you did on this one? No? Okay? So are we okay on this?
Yes, very much.
Okay, good. What we're going to do today is, with the remainder of class, we're going to start the next level of polynomial function.
Can we turn these in?
Yeah, you turn them in. What is the next level of polynomial function after this one?
Good question.
Exponents.
I don't even know what level it is.
Yeah, you can handle it.
Level 2.
Level
Actually, level 3. Oh, Lord.
What'd you say, Andrew?
More
What'd you
difficult.
say?
You said harder.
Harder? Yeah.
We're about to start.
Well, that was good work. Good work, K1.
Yeah.
I'll expose you.
Everybody is.
Secretary.
Okay, what would be logically the next type of polynomial function after linear?
Horizontal, I don't know. Circular.
Bro, you're so mad. I can tell you.
I don't remember what you said.
Quadratic, thank you, Angel. Yes, Angel got it. Angel says quadratic. Yeah, I'm gonna have to hand out some papers to you guys too, but I'll do that in a minute while I work on this stuff here. Okay. Okay, let's go on to, what we have here is, we're going to have some exercises on what Angel said. We're going to be graphing quadratic functions.
I can catch it. I will take no problem.
All right. Okay. So what do you know about this? This is what's called,
Parent function.
this is called the parent function, thank you. This is called the quadratic parent function. Okay. And what do we know about the parent function here?
It's a parabola.
It looks like a parabola, that's important to know.
Even.
It's an even function, very good. Man, you guys like
This one.
bounded below.
Wow.
Man, depth bounded below.
Its domain is infinity. I mean, all the numbers.
Domain is all around numbers.
Its range is
How's my
all
fist
the
bump?
numbers above 0.
Yes, and including
Good job,
zero. Yes,
Will.
exactly, good job. Now, so basically you recited for me all of the characteristics of this. Now, who else can tell me, since this is so advanced, what could you use this type of equation for in a real world situation?
Financial stuff.
Possibly, I wasn't thinking that. Possibly. Yeah, a bridge,
Yeah.
yeah, parabola, yeah, a stress-bearing construction, possibly. Also,
Roller coasters?
yeah, roller coasters possibly. Also, what happens is,
Wait, a satellite dish.
satellite dish, my gosh,
Satellite.
and flashlights, and
It does not feel like that.
I haven't been here.
and projectile and all that. So you guys remembered
Broke my leg.
You were there for that story whenever
Everything.
it hits once every spot.
Carmen said the slope of her life fall.
Yeah, see, you remember? Gosh, good job. Okay, gotta be careful what I say in this class. You'll remember too much what I say.
It's like we're all.
Yeah,
I
Remember
We're
it.
elephants whenever it comes to like unnecessary information. But whenever
Trivia.
we have to
Okay,
remember all this,
I can go with that, but not.
no, but it's helpful, okay? All right. What happens is a quadratic function, I'm gonna go ahead and draw a table, make a table. And we're going to learn about sketching.
Billy, shut up. I'm sorry.
Okay, we're going to learn about sketching quadratic functions. What it is, if you take 0, and what is our output for that?
0.
0.
No, we just have a.
And we go to 1, 2, 3.
L.
If we have 1 squared, what do we have? 1. 2 squared,
4.
4. 3 squared, 9. And then, because of symmetry, what's our axis of symmetry here?
Right. 0.
The y-axis. So if we go to -1, -2, -3, what are we going to get?
1, 4.
We're going to get the same situation over here. So we get 1, 4, 9. Now, what's going to happen is there's a certain pattern here. Is how much did we go up from 0 to 1?
1.
How much do we go up from 1 to 4?
3.
And how much do we go up from 4 to 9? 5.
I think that.
And then, similarly, we have, if we go the other direction, we have +1, +3, +5. You see that?
Yep.
Yeah.
Okay, and this can help us in sketching the graph of this function, that we can go to 0, 0. We have 1, 1, 2, 4, 3, 9. And because of symmetry, we have the same thing on the other side, right? And so we have a parabola that goes like this, don't we? And Will was the one I think who first said that today, didn't you, Will?
I think so.
And so we have these things here, and graphically, we can see in the table, we have +1 from 0 to 1, +3 from 1 to 4, and +5 from 4 to 9. So 1, 3, 5. So there's a pattern for quadratic functions. The pattern is this. It's going to be, if you multiply A by +1, +3, +5, you're going to have the pattern of progression for the parabola. And in this case, what is A?
The x-axis?
What number is A? In this case,
1.
A is 1. Who said 1?
3.
And
Oh, Hannah. Very good. A is 1. And so what we're going to do is we're going to look at other parabolas and be able to use different A's, and we're going to translate these things left and right. So translation left, translation right. What else can we do? Translate up and down.
Reflect,
We can reflect.
stretch.
We can stretch. And there are probably other ones too, but those are the ones we're going to go over. Okay, so you mentioned all of them. So let's go to this next one here, where we have y equals -2x squared. Okay, remember what our pattern is for this? Our pattern is A times +1, +3, +5. So what is A in this case?
2.
I don't get 2.
-2.
How about -2? So if we multiply these out, if we distribute our 2, what do we get here?
-2.
-2, -6, and -10. So now we have we can go ahead and enter this, xy, and we're going to start. Do we have our vertex right here at 0, 0?
No.
Yeah, we do, right?
Yeah.
Because- So 0, 0, and what do we do with our pattern here? going to be what?
Going down.
Minus 2, and then minus 6, and then minus 10. So what's 0 minus 2?
-2.
Negative 2. Negative 2 minus 6?
4. Negative 4. Wait.
Negative 8. And what's negative 8 minus 10?
Adam, your turn.
I'm taking a test.
-18.
Negative 18. And because of this pattern, we know of symmetry, what can we do down here? We can write the same numbers, right? Negative 2, negative 8, negative 18. So now we can go ahead and graph this. I want to make an XY coordinate plane. I will tell you sometimes it's sort of conventional to draw a standard parabola with 7 points, but sometimes because of limitations you might have room for only 5 points. Do you see why that? You got to make sure at least you can put the vertex there, and then 2 or 3 other points on each side of the vertex. Does that make sense?
Yeah.
So that's for a sketch. So now can we go ahead and plot these points?
I think so.
Yeah, so we got 0, 0. We got 1, negative 2. We got 2, negative 8. And so you can count from the x-axis 8 or just count 6 more. 1, 2, 3, 4, 5, 6. And then you can count how many more to get to this. 10. So counting 10, we get right here. Now how did I know that that was 10 without counting?
Maybe you've done this before.
I've done this before, even in 5th period. The reason is I know this is a 20 by 20 grid. So if I draw this x-axis up here, 2 below, I know negative 18 is down there. So that's why. And then because of symmetry, you go like this, and then this, and then this. And then do you have a parabola now? Yes, you do. So you go like this. And so how the parabola looks, what kind of graphical transformation was performed on the parent function here? Reflection across the x-axis, very good. And what else?
Compressed.
Well, a vertical what? A vertical stretch.
Yeah.
Vertical stretch and reflection about the x-axis. Okay, good. So does this look very hard? No? Okay. Really, it's really kind of a simple pattern, and people can have trouble sometimes with graphing quadratic functions, but if you remember this basic pattern, it shouldn't give you too much trouble. What I want you to do is do this one here pretty quickly, this g of x equals 1/2 x squared. Just see if you can get what that is here. While you do that, I'm going to go back.
What are the numbers again?
+1, +3, +5, yeah. Huh? Okay, good, that one's there. We're going to look at that later. Are some of you using your calculator to help you a little bit with arithmetic on this? Yeah, that's okay. If you are, that's okay. So what did you get when you multiplied by 1/2? What did you get for that? I got plus 1/2 plus 3/2, is that right? And plus 5/2. And so now if you use that, is this what you did? 0, 1, 2, 3, -1, -2, -3. So you had plus 1/2. And we start at 0, right? Start at 0. And then we have plus 1/2. And what's 0 plus 1/2? 1/2. And now plus 3/2, what do you get with plus 3/2? 2. And then finally plus 5/2, what did you get? So you can get 9/2 or 4.5. But once you have that, you just take this right here and you just put this on the other side like this. So 1/2, 2, 4.5. And then you got something that's pretty easy to graph, don't you? So we get something like this. Okay, we get 0, 0, 1.5, 2 is 2, and 3 is 4.5. And then symmetry gives you this looking thing here. And so this is what you have here, is that right?
Yeah.
So what kind of transformation is done to this function here? To the 1y equals x squared.
Vertical compression by factor of 2.
Vertical compression by factor of 1/2. Okay, good. Right? Everybody get that pretty well? I don't want to erase it. I'll leave it here for another half a minute. Okay, good.
Well, that was not a half a minute. Well,
There it is.
I think she was right. I don't think it was quite. I think it was more like 15 seconds.
So half
Half a minute, right. I was off by a factor of 1/2. Okay. Now I want you to look at this one here. Okay, this one here, 1/2 x squared minus 5. What does this one do here?
Translate 5 units to the right.
Pardon me?
Translate 5 units to the right.
Yeah, and so what it does, you're actually taking this one right here, and you're translating what? Down 5 units. Now 1, 2, 3, 4, 5. And then what happens to these? What happens to all these coordinates over here?
Subtract 5.
You subtract 5 from each one of them, and that's what you have. And so you'd have like -3 is going to be, subtract 5, you get like, I don't know, -0.5, -3, -4.5, -5. Okay, everything subtract 5. Okay, now let's go on. I want to show this one here. We got this one here, f of x equals x, quantity x plus 3 squared minus 4. What kind of transformation is done with this?
1 to the left of the units and 4 down.
So Angel says left 3 and 4 down, is that right? So let me go ahead and establish the vertex. We will say -3, comma -4, right? And really what we're doing is we're taking this parent function, aren't we? And we're taking it, as Angel says, 3 to the left and 4 down. So that one that I just showed is going to look like this, isn't it? So let's go ahead and look at that pretty quickly. I think we'll just finish there for today. So if we have this, but what is the value of A? A is equal to what? 1. So what is our pattern? Our pattern is going to be +1, +3, +5. And so now we can just go ahead and write it out like this. X, f of x. And we know that our vertex is at -3, comma -4, so we can just write that right in place. And for a table, what can we do? Go up, right? So we can go -2, -1, 0, and what goes over here? -4, -5, and -6. And now we still have our pattern, don't we? +1, +3, +5. So -4 + 1, -3. -3 + 3, 0, 0 + 5, 5. And now we can just do the same thing over here, right? -3, 0, 5. And now do we have something that we can graph? Yeah, we do. So let's go ahead and sketch that graph pretty quick. When you sketch a graph, one thing that's helpful to do is you can start out with an axis of symmetry. So we have X symmetry, I'll call it AOS, is X is equal to -3. In Algebra 2 Honors, did we talk about axis symmetry like that a little bit last year? It was a little while ago. And then we just go ahead and sketch these in. We have our vertex here, and then we can go +1, +3, +5, and over here +1, +3, +5. So there it is. So you've taken this thing, this parabola that was right here, and just shifted it 3 to the left and 4 down, as Angel told us, okay? And we're going to just leave it there today. Any questions before we go off camera?
No.
Nope.
Okay, thank you.
Thank you for watching.
Yes.